Hello everyone. This is it. This is our last lesson of SCH for you, 2020 semester 2. Okay. We are going to be doing this thing called balancing redox equations. Okay. So we've balanced chemical equations before. But in this situation, we're not just worrying about balancing atoms. We're balancing electrons. Okay, and we can do that one of two ways. The first way, which is what I'm going to show you in the first video, is using oxidation numbers, which you learnt about yesterday. Okay, and the second way is using half reactions. Okay, and that'll be the second video because one video at a time here. All right, so our situation is we're going to be dealing with a basic solution, and I'll show you the differences of that in just a moment, okay? And here is the equation that we're going to be dealing with right now. Okay, so right here. So first things first, we're dealing with oxidation numbers, and you've got to assign an oxidation number to each atom in this equation. So let's just go through and remind ourselves how to do this. So in the first situation, okay, MnO4 has, and I've already confused the issue, there we go, -1 charge. Okay, so that means both my manganese and my oxygen, when they combine together, they have to add up to equal a charge of -1. And if you remember back from grade 10, this is why I didn't like to teach you guys reverse crisscross or crisscross, because I knew this was eventually coming. So this is how we add everything up. So we know oxygen always has a charge of -2, and since there's 4 of them, 2 times -4 equals -8, right? So the manganese can be a bunch of different oxidation numbers, but we know that this has to add up to equal -1. So in this situation, we can assign manganese an oxidation number of 7. So I will do that. So manganese plus 7, and my oxygen is always -2, and this has an overall charge of 1. So there's my oxidation number for manganese. There's my oxidation number for oxygen, and that's the charge for the whole ion. Then H2S, it's a neutral compound, so it should equal 0. And we know in this situation, sulfur's -2. And that means this has to be +2. And since I have 2 hydrogens, each hydrogen is assigned 1, right? So I can assign my hydrogens as a +1. I can assign my sulfur as a -2. Then any element on its own in standard state has an oxidation number of 0. Any ion has an oxidation number of the ion charge. So we've got those. So now that we've identified our oxidation numbers, let's take a look and see who's changed. All right, so I can already see manganese has changed. And I can see that sulfur's changed. Okay, so I know that in this situation, manganese, I'm just going to write it out again. Actually, I'm just going to get rid of all these. Sorry about that. I'm going to get rid of all the oxidation numbers. They're not really necessary. So in this case, we'll refer because it just goops it up. There we go. Okay. So what happened from the manganese to the other manganese, you ask? Well, we went from, look up at step 1, we went from +7 to +2. Okay. So manganese gained from +7 to +2, this is where integers come into play, my friends. Okay, so they gained 5 electrons. So since manganese gained 5 electrons, we can say manganese was reduced. Okay, and my sulfur went from -2 to 0. So in this situation, my sulfur lost from -2 to 0, 2 electrons became more positive. So sulfur was oxidized. Okay, and if you ever have a situation where you have two entities either being oxidized or two entities being reduced, you've messed up somewhere. Okay, because one has to give and one has to take. Okay, that's how it works. These electrons don't just come from nowhere. So one has to be oxidized, one has to be reduced. But now we know. Okay, now the next situation is to balance the atoms. Notice what I'm saying. You're taking care of the atoms. So who do I care about right now? Well, we're caring about who actually changed oxidation numbers. So taking a look at the manganese, one manganese here, one manganese there. Check. That one's good. One sulfur here, one sulfur here. Check. Good. So we don't need to do this. So not necessary. The manganese and sulfur are balanced. Okay. In some situations, they won't be. So then you'll have to balance them just like you would normally for atoms. Okay. Now we've got to change, or we've got to figure out the change in oxidation number, and we got to make it balanced. Pretty much what that's saying is we've got to make the number of electrons gained equal the number of electrons lost. Okay, so that's what we're talking about. We're balancing redox. We're balancing electrons gained and electrons lost. So, more math skills. Okay, we lost 2, we gained 5. How are we going to make it equal? Well, this is like a common multiple. So ultimately, we've got to make them equal. So I guess the common multiple would be 10. So we are going to say that we're going to multiply manganese by 2, and we are going to multiply sulfur by 5. Therefore, 10 electrons were gained and lost, right? And that's equal. Okay, so when I do that, I'm going to put a 2 in front of my manganeses. So 2 MnO4 plus, and then where the sulfur is, I've got to put a 5 H2S. Okay, and then 5S on this side. See how my S's have to have 5, and then they're balanced too. And 2Mn plus 2. So just to recap why we did that, I multiplied the manganese by 2 because one manganese gained 5 electrons, so 2 manganeses are going to gain 10. Same thing, one sulfur lost 2 electrons, 5 sulfurs are going to lose 10. And 10 gained, 10 lost, things are balanced. Woohoo! Okay, then we're going to balance the remaining atoms by inspection. Okay, so what all that means is balance like usual. So my manganeses are taken care of. Follow me. 2 manganeses, 2 manganeses. Yay. Oxygen, we're going to worry about the oxygen atoms with this step. So that's not an issue. Hydrogen, hold on. We're going to worry about hydrogen atoms with this step. So don't worry about that. And sulfur, sulfur. So good. So once again, no other atoms to balance other than O and H, which we're going to take care of, okay? But normally, like say there was another atom in there, you would have to balance it at this stage of the game. Now, in that situation, this would be like a neutral solution. Now what we're going to do is if there's extra oxygen atoms, what we're going to see is we are going to use water to balance. And it's good to do this because most of these most of these reactions are in solution. So using water is no problem. Okay. So what we're going to find going up here, I'm just going to go to a different color. Okay. How many oxygens do I have? Well, I have 8 oxygens. And on this side, I've got 0 oxygens. So that means I'm going to add 8 waters to balance. Okay. So in this situation, 2MnO4. And so now I'm going to add 8 waters, because now that will give me 8 oxygens on the reactant side, 2 times 4, and 8 oxygens on the product side, 8 times 1. Okay, but I now have to worry about my hydrogens. So I got 16 hydrogens on this side and 10 hydrogens on this side. So I'm going to use H plus to balance my hydrogens. No problem. So I need, pretty much what that means is I've got to add 6 here. Okay, so I'm going to go 6 H plus 2MnO4, that doesn't change, plus 5 H2S, arrow. Okay, so as it stands right now, every atom is balanced, every electron is balanced, but this is where we would stop. Okay, this is where you would stop if you were in an acidic solution. But remember, hold on, don't get dizzy. I said this was a basic solution. Now, does this look like a basic solution to you? No, it doesn't. Okay, and that's why this would be an acidic solution, because you got leftover H pluses. The minute we have to remind ourselves that we're dealing with a basic solution, we've got to add the appropriate number of hydroxide ions. And pretty much what that means is add the same number of OH as there are H plus. Okay? And that's the way it goes. Because ultimately, in a basic solution, there can't be any H pluses left over. Okay? Because that's acidic. So you'll see what happens in just a minute. Hold with me. So, I'm just going to show you that. All right. So I'm getting mad at my iPad here. Okay, let's try this again. I have 6 H plus here. So what I do need to add is 6 OH minus. Okay, then I'll just continue. Now here's the other kicker. Can't just add OH to one side. What you do to one side, you've got to do to the other. So, okay, that's what you need to do. So what you do to one side, you have to do to the other. You can't just arbitrarily add 6 OH. Okay, now what you're going to see is that these two entities make up water. Okay, and so since these two entities make up water, we can cancel the water from both sides. Okay, so see what's going to happen. I've got 6 waters here. I've got 8 waters here. This whole business is going to go bye-bye. This 8 is going to become a 2 because 8 minus 6 is 2. And this OH remains. So my net answer is 2MnO4 minus 1 plus 5H2S 5S. Holy moly, that's a doozy. This is our final answer. Okay, and you know it's a basic solution because you got OH remaining. All right, that's how you do that. Now I'm going to stop, And what I'm going to recommend is at this stage of the game, try doing the homework on page 613, numbers 3 to 6. Okay, I'm going to stop the video because we have one more way of balancing to show you. All right? Okay, take care. I'll be back. You be back too. Don't go away.